We're going to construct Venn diagram to describe relationships between sets of rational numbers. The first set of numbers we're going to look at are the whole numbers. And the whole numbers fit into this smallest circle. They include the numbers 0, 1, 2, 3, and so on. What this means to be a whole number is that there are no fractional parts or decimal parts. It's just the whole number. The next one we're going to look at is the integers. Now the integers, notice that the whole number circle fits inside the entire integer circle. That means that the integers are all the whole numbers plus their negatives. So coming from a negative standpoint, we are going to add negatives 3, negative 2, negative 1, and so on. And we've now continued up because the next one would have been 0, 1, 2, 3. So integers include all of the whole numbers inside that circle plus their negatives. And the final category we're going to look at today is the rational numbers. And the rational numbers are right here in their name, ratio. So a ratio, if you recall, is anything that can be written and in the form of A over B, or A to B, so long as B is not equal to 0, because we cannot have 0 in a denominator. So as we look at these, some of the rational numbers will be they'll be a little tricky to see and to identify. So let's talk about some of those. For example, the number 2. Well, the number 2 we know is a whole number. It's also an integer, but it's also rational because we can write it in the form of A over B. Another rational number that may not seem quite as obvious as just any fraction would be a number such as 0.5. The reason this is also rational is because we can make that into a ratio of 1 over 2. We could also make it 5 over 10. There's lots of options there for us, but we can turn 0.5 into a ratio of two numbers. And the final one we're going to look at today for rational numbers that might not be as obvious as we'd like them to be is a repeating decimal. So for example, the decimal 0.3 repeating, we can use our algebra to prove that 0.3 repeating is equal to 1 over 3 and therefore rational. So as we look at these decimals, any number can be put over a 1 and you can create a ratio. Any fraction that you get, for example, 3/4, that of course is in the format of A to B. It's a ratio. But for these decimals, you're looking for two specific rules. So decimal rules. And this is decimal rules for rational numbers. The decimal rules are 1, the decimal must be terminating. Terminating as in the 0.5 example above, the decimal stops. It's terminating. It stops because it terminates at 0.5. There's nothing else with it. And the other thing we're looking for is a repeating. And it does not matter how long it repeats. So, for example, I gave the example of 0.3, just one decimal point repeating, but you want to go a little bit further into your research if you're ever asked to identify these numbers in the future, because repeating decimals, for example, 0.123456789, 123456789, 123456789. That is a repeating decimal. It's just a very long one before it repeats. So those are the rational numbers. And then what you're going to do for part B is you're just going to come down here and identify what statements are true and which statements are false. Be very careful about double negatives down here, but all whole numbers are integers. Well, if I look at my list of all my whole numbers, I can see that yes, they fit completely into the integer category. So yes, all whole numbers are in the integer box or in the integer circle. So that would be true. All rational numbers are whole. Well, with this one, we look and we see that there are going to be some rationals out here that are not inside the whole number circle. So that one would be false. And that's how you're going to do this on all of these. You're just going to sit and you're going to look at your Venn diagram and decide, is this a true statement? Do all of these numbers fit inside this other category, or are some of them outside that category? And again, watch for the double negatives.